Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Okay, so before we even get started at this, I think you probably want to pause the video. If you are going to follow along, you're going to want to go find some space to work in, and you're going to want to find your really good compass. So if you have a cheap compass sorry, that's me moving all my pens out of the way. I needed the space. If you have a surface that's kind of got a lot of stuff around it, or if you have a compass that kind of falls in or something like that, you might want to change things up a little bit. So we're going to first start with our perpendicular bisectors in an acute triangle. Then we're going to do it in an obtuse triangle. Okay? So, and we're going to see what happens with each. So kind of a neat little thing, things that we can kind of go about. All right, so an acute triangle, remember, is just one that has three corners less than 90 degrees. I made sure to put it at an angle because I wanted it to be at an angle. Okay, so first off, I'm going to draw all three perpendicular bisectors, okay? And I am going to end up color coding, so I don't have my pens too far, but I want you to kind of see what's going on. So if you remember correctly, we kind of need to, I'm going to focus on BC first. So this is more than halfway. And technically you can just make a half circle. You can move your paper if you want. You can move your compass, however you're going to do it. See if I move my paper. That's why I move my pens. Because I think it's easier to move my paper than it is to do the compass. In this case, I'm just going to do that. Okay. So we have this going on here, right? Now remember, I'm going to need some kind of straight edge to be able to go ahead and mark this. Okay. Actually, I just use a mirror, using the actual mirror this time instead of the whole mirror case, because I want to be able to make this a little bit thinner and a little bit neater. So I'm going to come in. My glue fell off the back, which is why my mirror has been rattling around in my case. And I have it upside down because I don't want the shine glare to be reflecting back at anyone. So we now know that is our 90-degree angle. So we don't need those marks anymore. You can stop, you can erase it, whatever. Now that we did BC, right? Now I need to do A to B. So put that over to the side. We don't need to worry about it. Am I more than halfway? Maybe. Let's see. It's kind of close, so I'm going to make sure I go a bit bigger. Okay. So again, half circle from A. Half circle from B. And I'm going to go ahead and connect those. So this time I'm going to use a different color. Let's see, we'll go with purple this time. And that's where it's perpendicular. And we know that it cut those in half because that was the perpendicular bisector, right? Okay. And what about AC? Okay, so I'm going to do a bigger circle because AC looks like it's longer. And there we go. And there we go. And I'm going to connect those. And this is why I say you might want to erase things. As you see, it's already getting a bit full, for lack of a better way of saying it. So here in a minute, I'm going to erase all my work marks. Am I off? Nope, I'm not off. Maybe a smidge. Okay, so one thing that you really have to be cautious of is that sometimes just the width of your pencil can make you get a little bit off, or maybe you lined it up a smidge off. So keep in mind, if you've messed up and you're really close, then understand that the width of your pencil lead can cause errors, or maybe you lined up your straight edge just a smidge off. But what you should have noticed, had everything worked out perfectly, is that my 3 perpendicular bisectors all met at a point. The purple, the green, and the brown all met right here. I'm going to call that point P. But not only did they meet there, something else interesting happened. Look at the distance, and hopefully you've been following along and doing the same on your paper. Look at the distance from the point where they met to each vertex of your triangle. Let's get that there. And Hey, would you look at that? I started with a triangle, and now I have a circle. I got a little bit wobbly. Whew. Okay, this is the importance of making sure you stay on track with all your things and not letting it slip. You have a circle that actually goes around, and P to A is congruent to P to B, and is congruent to P to C because it's the radius of that circle, right? Okay, so that was an acute triangle. What if we did an obtuse triangle? Okay, make sure that when you draw it, you get an obvious obtuse. All right, shorten this up. We'll do the long side first. Not drawing the full half circle this time, only enough, whoops. I was gonna say only enough to get X marks the spot, but sometimes doing that, notice how I didn't go far enough. There we go. Find the mirror with the glue on the back, that's a bit interesting. All right, there's one perpendicular bisector. Erase all those pencil marks, that way they don't get in our way later. And remember, that was for this line. That's why I used these 2 corners. Shorten this thing up so my circles don't have to be so big. Mark. I'm actually just going to go ahead and do, I'm going to cheat and make a full circle here. You'll see why in a second. Maybe I should have taken my own advice and moved my paper. And a half circle from here. Okay, so see how I made 2 different like football shapes? So when I connect here, but when I connect, oh, I forgot to mark which one that one was. There we go. Trying to make sure I line everything up really well. There we go. Now I can erase all those marks. And this time they did come together again. Let's check out if the same thing happened, right? Looks like I might have got a smidge off with one of my marks. Ah, it was my first one. It looks like it was off. That's the thing, is by drawing all three of them, you can double check your work, because guess what? They are supposed to all meet in one spot, and it's supposed to, here, get all my eraser marks out of the way. All right, I'm gonna go ahead and, since I got off on this one, instead of just going through it that way, I have it right here as well. I've drawn a different triangle here that made it a lot prettier. And we can see then, sometimes you just need to make sure you're really careful with the width of your pen. That yes, that distance, bring my compass in a smidge, it was a little wide, is going to be congruent to, yep, is going to be congruent to, yep. Could I make a circle like that now? Absolutely, especially if you don't get off. So see, you might notice here that this has a thinner pencil width than the compass I'm currently using, and that really can make a difference. So this is why I highlight the fact that, hey, your compass really needs to be a good compass. So these three lines happen to meet in both times out. This time they were outside the circle. Could it meet inside the circle? Absolutely. Okay? Where these three lines meet is your point of concurrency. And every time you do the perpendicular bisectors, you should have a point of concurrency. Okay? Now the fun thing is, okay, so you could start with any triangle, draw all three perpendicular bisectors, label P as the point of concurrency, and then you could draw a circle. With center P. So I went ahead and got that on there for us. That way you didn't have to take time to watch me drawing my quick. So yes, absolutely, your perpendicular bisectors are going to be connecting at point P. So could I come in here and go and just go through point P and let you see that yes, yep, that's going to be perpendicular. So and I freehanded my triangle. I did not use a straight edge for my triangle, so please keep that in mind. Ooh, and that's sliding all around too. So make sure that you're very careful with your drawings. That's kind of the big thing. But this is called a circumcenter. Okay? So a circumcenter happens when you have three perpendicular bisectors, and they're going to come together all at once. Perfect. So what happened? And you'll notice that the circle goes around the outside, right? So now we can, how can you get a circle through any 3 points? You draw all the three perpendicular bisectors. So if those are the perpendicular bisectors, what happens with angular bisectors? Okay. Well, this works better with acute angle triangles than it does obtuse triangles, but you can do it with obtuse triangles as well. It's just you'll have a much tinier workspace. So if you recall, for an angle bisector, you're not going to need your compass as big. So I'm just going to do a small circle at each vertex of the graph, or this triangle right quick, because that way it's fast and easy. You don't even have to do a full circle, you can just do a arc, as long as it touches the two sides of the triangle. So, arc, arc, and, ooh, it's sliding around on me now. And this arc's gonna have to be bigger, that's okay. All right, so from each of those we need an X marks the spot. So this is why sometimes you have to be careful about how many marks you have on your page at one time. Okay, I'm definitely seeing where those are going to come together for the first corner. So handy dandy little straight edge here. Line it up as well as you can. Okay. Come over here. X marks the spot. Oh, I should have made the other one a little bit longer. Sometimes a bigger radius does help out. Sometimes a smaller radius works out whenever you're using your compass. But do as much accuracy as you can. So we're noticing that these are already starting to come together. So will our third one come together in the same spot? For this one, we're probably going to need a wider, I'm going to go ahead and widen this out. It was a bigger angle. Whoops, helps to have the pointy spot in the right spot. There's a mark. And there's a mark. So see how flat this got, where this was more X-like? It's because I increased the size of my compass so that it would be more accurate, and go from that angle. Okay, I think my brown one might have got off. I'm going to do my brown one more time. I'm going to use this bigger angle here. Maybe a smidge. What about my green one? Is my green one the one that's off? Oh yeah, my green one's the one that's off. See how I did get off on drawing it? Let's bring that green one up to par, because it's the one that's off. Wasn't off by much, but enough that it did affect my point of concurrency right there in the middle. Okay, now this is definitely not equal distance to each of them, right? But one thing that you can do is if you keep going smaller. We now have a circle inside the triangle instead of outside with all my crazy marks. Cool. All right, so trying to keep this drawn straight and under the camera is sometimes a pain. So again, angle bisectors, connect them all together, right? And now your point of concurrency is again, but now it's equidistant. The point, but it's not the vertices that it's equidistance to. It's an inside circle, not an outside. And so therefore it's called an inscribed circle, and you have an incenter. And your radius is going to be perpendicular to each side. Okay? So as long as you construct something perpendicular, you're going to have your radius. And you get the circle on the inside. Hence an inscribed circle instead of a circumscribed. It's inside. So we have the incenter. Okay, so I know that's just kind of a weird thing if I draw my, okay? So that's really the big idea of it. If you draw 3 perpendicular bisectors, your circle is going to go around or circumscribe. Right? Ooh, hey, come on, there we go. If you do 3 angle bisectors, your circle is going to be on the inside or inscribed. So it's kind of a cool thing that these drawings happen, but there's a lot of other relationships that can pop in because of this. Okay? Specifically that the center to the vertex will be your equidistances. Okay? Where here is the center to a perpendicular spot on the edge will be equidistance. Okay, so I probably should write that bigger or just zoom in. So the center to the vertex will be equidistance here. The center to a perpendicular on the edge will be equidistance. So what would you do with that? Okay, it's just understanding the difference here. So let's say I gave you a big triangle ABC. Okay, and I drew this and marked it, and I drew this and I marked it. Okay, so we've got that, right? Now, this isn't quite perpendicular, right? Perpendicular would be right here. So that's going to be the radius of the circle on the inside, if I've drawn this correctly. Again, I'm shorthanding, I'm just marking it. We don't actually care about this part right here or this part right here. Okay, we just care about that. So let me go ahead and give you some letters. A, B, C. Okay, they come together at F. And we have D. Oops, I wanted to call that. Oh well. And we have E. If E to F is 3y minus 5, and D to F is 2y plus 4, what is the distance from F to the line AC? Which isn't even drawn, right? Okay, because I marked that these were angle bisectors, my drawing is definitely not to scale, because what should happen is that this short distance and this short distance and this short distance should all be the same, because angle bisectors result in a circle inscribed. So if we could solve for y, we could find out f to AC, because it should just be a radius of a circle. So these should also be radius of the same circle, or radii. So 3y minus 5 should equal 2y plus 4. So y should equal 9. Now that's not the answer to the question. Okay, so 3 times 9 is 27. 27 minus 5 is 22. 2 times 9 is 18. 18 plus 4 is 22. So the distance from the center to the side should be 22. When you're looking at textbooks, hopefully they've drawn things well. If they haven't drawn things well, you're going to have to think about it and things like that. So I find that this starts to get into a lot of sections where students start mixing things up, okay? So we're going to kind of, and I'm going to refer back to this occasionally. Okay. Angle bisectors, incenter, circle inside triangle. Okay. Radius perpendicular to the side of the triangle. Okay. Perpendicular bisectors. Circumcenter. Circle outside the triangle. Radius equal vertex to center. Okay, and I'm going to add to this in future videos, but kind of keeping that running chart going is really a big deal.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.